Welcome to Study Loop.
This is the answer to Chapter 16, problem number 57 from the Smith Organic Chemistry textbook. And this problem asks us to devise a stepwise synthesis of each of these three compounds that were given, starting from dicyclopentadiene, using a Diels-Alder reaction as one step. And we're told we can also use organic compounds having less than or equal to 4 carbons and any required organic or inorganic reagents. Okay, and so for each of these, starting from dicyclopentadiene, the first thing that we have to do is going to be to do a reverse Diels-Alder reaction to take our dicyclopentadiene and instead get 2 equivalents of cyclopentadiene. So we're going from a much more complex starting material here to a simple starting material, or at least a more simple starting material. So we'll get 2 equivalents of cyclopentadiene, and then we'll actually use cyclopentadiene as our starting material for each of these syntheses. Okay, and so like I just said, we'll start from cyclopentadiene. And so for A, the first thing that we're going to do is going to be to use the Diels-Alder reaction. So if we do that, our product will be this molecule. And so, and we do need to include heat. So it's important not to forget that, as I just did. And so from here, from this product, we need to do a syn dihydroxylation in order to get our desired product for A. And so we can do a syn dihydroxylation using osmium tetroxide, followed by workup with NaHSO3 and water. And so when we use those reagents, we get a syn dihydroxylation. And so our 2 OH groups will add like this. And so that is our desired product for A. So that's good. So then for B and also for C, as I said, we will start from cyclopentadiene. We don't need to redraw how to get to cyclopentadiene each time from dicyclopentadiene. And so starting from cyclopentadiene here, we will do a Diels-Alder with this molecule. Started too high. So this will be our dienophile for the Diels-Alder. And so we do need to heat it. And when we heat these 2 reagents together, we end up with this molecule. And again, let me bring this down. I don't know why I keep underestimating how big I'm going to draw these things. So we'll get this. And then our fused ring will look like this. So our oxygen's there. carbonyls are here and here. And then from here, we need to epoxidize that double bond. And so that is easily done with MCPBA, metachlorobenzoic acid. Metachloroperbenzoic acid, benzoic acid. And so, as I said, we can do that easily with MCPBA. And that is really only going to affect that particular double bond. So everything else about this molecule will stay the same. So here are our carbonyls. And so now we will have the epoxide here. And that's the product that we want for B. So that's going to be our final product for B. All right. And so lastly for C, again, we will start from cyclopentadiene. And again, we'll start with Diels-Alder. Oops. So actually, we should use the aldehyde here. So CHO, it's going to be the aldehyde. We have to heat it. And so our product is going to be this. And we have the aldehyde here. Okay. And so now we need to reduce the double bond. And so we can do that with excess hydrogen gas and a palladium catalyst. So palladium on carbon. And so that is going to reduce our double bond. And so the last thing that we need to do is, it's going to be excess hydrogen gas. And I guess I should say excess. So it's going to be excess hydrogen gas. And that's important because it's also going to reduce our aldehyde. So instead of the aldehyde, we'll have the alcohol here. And now to get from the alcohol to the ether, we can deprotonate it with a strong base like sodium hydride. And then we can just use, so we need the butyl ether. And so we can just use bromobutane. So that, and after that, we will be at our desired final product here. Okay, and so there we go. That's the sequence that'll give us that product. And so again, for each of these, we started from cyclopentadiene, and at the top here of the first page, I've just drawn the reaction that's going to give us two equivalents of cyclopentadiene from dicyclopentadiene. And then each of these proceeds starting with the Diels-Alder reaction and then just modifying some functionalities using reagent sets that we already know from other chapters. And that's the answer to chapter 16, problem number 57.